All right, so let's talk about why we know that the square root of 2 is irrational. And this story actually starts with a guy named Pythagoras, who you have probably heard of. He was this ancient Greek dude who, among other things, told us that in a right triangle, a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. He actually also had a school where he taught math, and he also had a religion based entirely around math. And one of the core beliefs in his religion was that everything in the natural world could be expressed either as a whole number or as a ratio of whole numbers, which is just a fancy way of saying that everything could be expressed as a fraction. So he had this student by the name of Hippasus, and Hippasus was sitting around one day thinking about stuff, and he asked himself, what is the ratio that describes the diagonal of a unit square? So a square with side length 1, we know from the Pythagorean theorem that the length of that diagonal is the square root of 2. And he said, okay, I know that it's the square root of 2, and I know, based on my math religion, that that's a fraction. So I'm going to say that the square root of 2 is equal to a over b. I want to learn some things about a and b here so I know what that fraction actually is. First thing I notice is that there's a radical in that equation. Those are kind of unpleasant. Let me square both sides. So next 2 equals a squared over b squared. And now there's a fraction. I don't like that so much either. So I'm going to turn that into 2b squared equals a squared. Now he says, aha, I'm getting somewhere. I can see at this point that a squared is even. And if a squared is even, I can also conclude that a is even. So since a is an even number, I can say that a is equal to 2c for some other number c, because every even number is double another number. Substituting that in, I have 2b squared equals 2c in parentheses squared, which is the same as 2b squared equals 4c squared. And I can divide both sides by 2 and get that b squared equals 2c squared. Aha, I'm getting somewhere again. Now I can see that b squared is even. And if b squared is even, that also means that b has to be even, which means that I can write b as 2 times d for some other number d. I can do that same substitution again. 2d in parentheses squared equals 2c squared. 4d squared equals 2c squared. 2d squared equals c squared. And then at that point, c squared is even, and c is even, and wait a minute, something is very wrong here. Because at this point, it's very, very, very clear that I can keep on doing this process until I run out of letters and start making up new letters to keep doing it with, and just grow old and die, finding more and more and more even numbers. And that doesn't make sense because there are not any fractions out there that you can simplify infinitely many times. There are not any numbers out there that you can divide by 2 infinitely many times and still get an integer. So this doesn't work. This doesn't make sense. So then Hippasus starts to think to himself, maybe the square root of 2 can't be expressed as a fraction. Like maybe we were wrong about this. So he goes to see Pythagoras and he says, so Pythagoras, I was thinking about the square root of 2 and something wasn't quite making sense here. Can we talk about it? Pythagoras says, sure, friend, let's go out on a boat and talk about this together. And Pythagoras came back from that boat ride alone because you're not supposed to question your religion to the person who's in charge of the religion. The good news is that your math teacher is hopefully a little bit more forgiving than this. And also, we now know that irrational numbers exist, thanks in part to Hippasus.